we are looking at three variables, w, x, and y. Z is only here to store the maximum. But I'm only trying to find the maximum of w, x, and y, but z is only here to store it. All right? Now, this is actually the way I write programs too. Okay, I don't write programs from line 1 to line 10, in that particular order. Line 1, line 2, line 3. I always, kind of jump around like this, to work on the logic. Okay? When you're working on your homework assignments in cisp300, I personally would not expect myself to write programs in a really sequential manner because I cannot plan that far ahead of time. Okay, I can only work on one part of the program at a time, so I will do the same thing as what I'm doing here. Some of you may be better programmers than I am, so you can do it without using this technique. All right, so now I have 3 lines here, just so that I can fit the skeleton of another conditional statement. At this point, with this, right after the else on line 7, at this point I know w is less than x, right? Because the only reason I would end up here is w is greater than or equal to x is false, which also means that w is less than x, which means w cannot be the maximum. I only got 2 variables left that can be the maximum, x versus y. So this time I will have a comparison between those two. If x is greater than or equal to y, then I do something, else I do something else, and then end if. Okay? And once again, I will go back here and insert this row, and now I try to figure out what I'm supposed to do here. The only reason I can end up here is x is greater than or equal to x is false, which means x is less than, w is greater than or equal to x is false, which means w is less than x. And then the second condition that has to be true in order to end up here is x is greater than or equal to y. So w cannot be the maximum, but because x is greater than or equal to y, x has to be the maximum in this case. May not be unique, okay? X and y can have the same value, but if they do have the same value, there's nothing wrong with picking x as the maximum. So at this point, I can confirm that and just say, oops, wrong line, wrong cell. X is, z gets the value of x because x is at least one of the maximum variables. And then the next one, let me insert another row here. Okay, since we were down to between x and y, if I'm in this else, that means x is greater than or equal to y is false, which also means x is less than y. Well, since we're only down to x versus y, if x is not the maximum, it has to be y now. So z gets the value of y, and now my entire algorithm is done. I just rewrote the max3 algorithm in a form where I use nested conditional statements. Are there any questions about this particular algorithm that uses nesting, the structure?
Don't we need something else on the end?
Sorry?
Do we need another line in case w is less than x initially?
If w is less than x initially, it will go to here. Okay, so let's take a look at this logic.
Right. Okay.
Okay, all right. Okay, very good. Let's trace it. Okay. Now, once again, tracing an algorithm is not the proper way to make sure that the algorithm is correct. But nonetheless, in this class, this is one of the techniques where we can just say, okay, let's see if we understand how this algorithm works. Now, looking at this algorithm, what would be the minimum number of test cases needed to make sure that it is correct? Absolute minimum.
4 and 5.
At least 4, okay? We need at least 4 test cases to make sure this is correct because there are 4 possible branches. 1, 2, 3, 4. These are the 4 possible branches. And we have to make sure that we get to these branches at the right time, under the right conditions. So that's why there are at least 4 test cases required if you want to use a trace or the technique of tracing to kind of verify this program is correct. You will need at least 4 test cases. I'm not going to do all 4. I'm going to do maybe 1 or 2 just to illustrate how to go through code like this. All right. So let's go ahead and make a new sheet just for the trace. Use this, need comments, line number, X, W, X, Y, Z. These can be a little bit narrower. Well, this time I do need to give you some precondition about W, X, Y, because otherwise there's no way to trace the code. So let's go ahead and start with 617. Z can be unknown because we know that if we take one of these 4 branches, Z will be changed anyway. So we start with line 1 here. Line 1 is W versus X. W is greater than or equal to X is true. Okay. So where do we go next? Go to line 2 because the then condition, or the condition is true, we go to the then branch, which starts on line 2. Line 2 is the beginning of another conditional statement. This one is nested in the one that we were dealing with earlier. So W versus Y this time, is that true or false? That is false. So we cannot go to the then branch of the inner conditional statement, which is line 3. We have to go to the else branch of the inner conditional statement, which is on line 5. Line 5 is going to copy the value of Y to Z. Y has a value of 7 at this point, so Z will end up with the same value. And then what do? We are now at the end of the inner conditional statement. So that means we are now, it's time to get out of the inner conditional statement. Is there anything following the inner conditional statement? In other words, is there anything following line 6? Nope. There's nothing following line 6. Okay, let's trace the program. We executed line 1, then we execute line 2, and then we execute line 5. Now when we are done with line 5, we are done with the else branch of the inner conditional statement. So now we are technically done with this statement here. Where do we go next? We go to post. There's nothing else to execute. So in the trace, we just say post. We're done. Now this part is very important. The other way to visualize this is to draw a picture. Okay, if you draw a picture, then you will clearly see why we are getting out of the entire pseudocode after line 5 executes. Because we are at the merge of the inner conditional statement. After it merges, it will start to merge with the other branch of the outer conditional statement. And yet there's nothing to do at that point. And that's why we are going all the way out of the entire pseudocode in this case. If I had something on line 14, I would be going to line 14. But since I don't, we're going to post in this case. Are there any questions about this pseudocode and the trace of it? No questions? All right. If there are no questions, we'll keep going forward. All right. Close that. And we are technically done with topic 2 at this point. We are moving on to topic 3. So let me turn on editing so I can highlight the next topic. So we are now moving on to topic 3, which has to do with logical. Whoop, this is it's grayed out, which means you cannot see it. So we're moving on to topic 4. I'm going to turn on the highlighting of this topic so that you can see clearly when you log into Moodle where we are at. Topic 4 is, let's just say, an interesting topic. We are making a very clean break from topic 3 because in topic 4, we don't trace anything. Instead, we deal with pre and post conditions of a statement. Now that is really something that, how should I put it? It's, I think it is the core of computer science. Okay, this is really, really important when someone wants to become a developer. And yet, a lot of people look at this stuff and go like, I don't think I really need to know this stuff to become a programmer. So it's something that may be a little bit controversial. So we'll go ahead and just take a look at the slide here. If you want to take the practice exam, that's fine. The archive here let me see what format did I save it in. It's a tar.gz file, which means you cannot, Windows doesn't know how to open that file natively. You can go ahead and download 7-zip, it can deal with your tar.gz files in that case. I can also resave it as a zip file for convenience. But before we go there, because I think it's way too early to go to the practice test, let's go ahead and talk about pre and post conditions. And I'll use, which one should I pick? Let's pick that. Okay. The first slide talks about what is this crazy math, because it is crazy math, okay? Let me show you what crazy math we are talking about here. Okay, a very familiar conditional statement. And then we have all this stuff here, and then we want to come to this conclusion, post 5 is this mess here. Okay, so it is math, okay? At this point, this is more like a math class than a programming class. But before we get to the crazy stuff, let's go ahead and find out why we are here. In other words, the rationale of this entire module. Okay. I know this is a lot of text. I don't want to read it. I just want to, you need to read it before the class, but I'm not going to read it during the class. What happened in year 1999? As far as computers, industry, software is concerned, what happened in 1999? Yep.
Y2K?
Y2K was one of the things, okay, but there was another thing. There was another thing going on in 1999.
The double digits? And the year ending, instead of having the 4 digits,
Right.
all programs into 2?
Yeah, we got that thing. Yep, we have that happening too. And then the third thing was, was year 2000 a leap year, or was it not a leap year? How many people remember? It was a leap year. Okay. Now, what are the rules for leap versus non-leap? Every 4 year is a leap year, and then how many years? How many years is not a leap? Every 100 is not a leap year. And then after 100, was it 500 or 400? Every 4 or 500 is a leap year again, and year 2000 falls into that. So year 2000 was a leap year because of that. Okay. Why do we have all these strange rules about leap year? This year is leap, this leap year is not, and so on.
We have to count up 4 to be extra, like a quarter hour a day, correct?
It's not exactly a quarter hour.
Or whatever the...
When you measure the number of Earth self-rotation versus the rotation or the orbit around the sun is an irrational number. Okay, and as an irrational number, it means it will take an infinite number of digits to represent the actual value. In other words, we can never, ever, actually write out how many days there are in a year. Some people say it's 365. Some people get more precise to be 365 and in 1/4 of a day. Those are all approximations. As an irrational number, like pi or e and so on, it never ends. Okay, so the rules that we have, can only account for up to a certain amount of time, but it is not, exact either. Okay, but anyway, it's just a digression here. Year 1999 and year 2000 is also known as the boom of the dot-com years, right?